Mac here. Today I'm going to do some solutions for the practice set on 3-4 on composition of functions. And let's do 1 through 19 for this video. Okay, so let's take a look at the first one. How does one find the domain of the quotient of two functions f divided by g? Okay, so we know that g of x here, which is the function that we're dividing here, g of x cannot be 0. 0. Okay, so, because we can't divide by 0. So whatever the function f is, dividing by 0 is undefined. So we need to find the domain for g so that g of x is not 0. Okay, maybe we just write it like that. Now f of x, or the function in the numerator here, we're not going to be dividing by 0 here with f of x. Well, I guess it's possible that there's a divide by 0. But what we're mainly looking at in the f of x is could have a domain restriction if there is a square root, right, or an even root in the numerator. Let's say can't take the even root of a negative number, right? And so by taking those two things into consideration, dividing by 0 or having a root that is a negative, a radicand that is negative, we can kind of figure out what the domain will be for that function. And I'm going to go with that. Looks pretty good. Let's stick it in here. All right, there's our verbal. Okay, so it's going to take me an eternity to move this up. Here we go. Okay. For the following exercises, determine the domain of each function in interval notation. Okay, so we are looking for f plus g. All right, so f plus g, let's get this in a color. F plus g of x is the same as saying f of x plus g of x. Okay, so f of x we're calling x squared plus 2x. And we're going to add the g of x to that. And the g of x is 6 minus x squared. And let's see. If we add like terms, x squared minus x squared cancels, and we're left with 2x plus 6. So f plus g of f is 2x plus 6. So let's see. In this domain, the whole way that we went through on each line here, we were never dividing by 0. We never had a radical that could be a negative radicand. So our domain for this, maybe I'll just put it here. Our domain is going to be negative infinity to infinity. We didn't have any restrictions. Okay. So that one's done. Let's take a look at the next one. Now we're going to subtract the two functions, f minus g of x. So that's the same thing as saying f of x minus g of x. So that's going to be x squared plus 2x minus, now as I'm subtracting this function, it's important to make sure that we write the quantity here because we have to distribute this negative. So this is going to be a negative 6 and a plus x squared here. So this is going to be 2x squared plus 2x minus 6. And as we see in each one of these, as we set this equation up, there's nothing being divided by 0 here. There's no radicals. So our domain is going to be all real numbers here, negative infinity to infinity. All right, that one's done. Let's have a look at f times g. So fg of x, now this is not f of x yet, this is just f times. We see there's no symbol here, so that's multiply. So this is the same as saying f of x times g of x, x squared plus 2x times 6 minus x squared. Again, not dividing by x and no radicals, so this looks like it's going to be pretty good for us as far as the domain. I'm going to FOIL this. Okay, x squared times 6 is 6x. X squared times negative x squared is negative x to the 4th. 2x times 6 is 12x. 2x times negative x squared is negative 2x cubed. And then, so maybe I'll just write this in descending order. Okay, that's fg of x. And I don't see any restrictions here on this domain. Last one. Okay, we're dividing here, so I think this is a red flag. Okay, so f of x is x squared plus 2x, and we're dividing this by 6 minus x squared. Okay, we have an x in the denominator, so we cannot have this be 0. Cannot be 0. Okay, so you should be asking yourself, what makes it 0? Right? So we're going to say 6, maybe I'll make this red. 6 minus x squared equals 0. Right? What makes this 0? Well, just set the whole denominator equal to 0. Let's solve it. Divide both sides by a negative. Now we have to take the square root of both sides, but I want you guys to be careful here. When we take the square root, we get a plus or minus root 6. This does not work. Plus root 6 or negative root 6 will not work in here. It'll give us a divide by 0 situation. All right, so this means my domain is going to go from negative infinity to negative root 6. Okay? Below negative root 6 is fine. Then we have a unity here, and then we can go between root 6, negative root 6, and positive root 6. Okay, for instance, 0 would be okay. 0 is in here somewhere. That's fine. And then also from root 6 to infinity. All right, all those are going to be good for this. There's 3 different intervals there that work because we have 2 wholes, plus or minus root 6. All right, number 7. A little bit of work with these. So f plus g. Just adding these here. 2x squared plus 4x plus 1 over 2x. Okay, we could add these together. I could multiply everything through by 2x here and get a common denominator. I think I'm going to leave it like this, but what do we notice right here in this denominator? There's an x. So what value of x makes this 0? We could just set this equal to 0 right here and then solve. Isn't it 0? 0 does not work for this function. Okay, it gives us a divide by 0 scenario. So my domain is going to go from negative infinity to 0, and then also 0 to infinity. There's that hole right there at 0. Man, this is not a bracket where it includes. This does not include before 0. It includes everything before 0 and everything after, but not actually 0. Okay, I hope you see we're going to see the same thing when we subtract. The only thing that changes is right here. We say minus 1 over 2x. But you see there's still that 2x in the denominator. So that's still going to have a hole at 0. So this is going to be the same domain here. Okay, what if we multiply? F times g of x. So, this will simplify. If I multiply through 1 over 2x, it'll cancel a 2 and an x there. And this will cancel a 2x out of this, right? And leaves us with 2. Like 4x divided by 2x is 2. And you might say, oh, there's no divide by 0, but there's the divide by 0 in the beginning right there. So we still have to take that into consideration and say, yep, we multiply, it ends up canceling that denominator, but we still have a domain restriction. Even though that canceled, we have to consider that a hole. Okay, so it's still the same as the other ones. And then the last one, f divided by g. What do we have? 2x squared plus 4x divided by 1 over 2x. Still, we could simplify this. In fact, we can. We can multiply top and bottom by 2x to get rid of this, right? And that will give us 4x cubed plus 8x squared. You might say, oh, there's no divide by 0, but we had it right here in the beginning. So there's still going to be a hole here at 0. Okay, 7 is done. Okay. 9. Yeah, I think these get a little bit easier as we go. There seems to be a little bit more work for 7, 8, 9. It's okay. F plus g of x here. Okay, so we're going to add these two together. So, we got to be careful when we see radicals. This is an even one here. So, we could take the square root of 0, but we can't take the square root of a negative. So this quantity right here, cannot be negative. So this means that x minus 5 has to be greater or equal to 0. Okay? So that means x is greater than or equal to 5. So 4 doesn't work, right, because that would give me a negative 1 under the radical. 5 would be 0, that's okay. So we do have a domain constraint here. So that means we're at 5, Let's make that a bracket. Includes 5. And we're going everything to positive infinity. Okay. Look, f minus g is going to be the same. Okay, the only thing changes is a sign here. It's just minus. But the radical is the same, and we still have the same restriction, right? We've set this equal to 0, greater than or equal to 0, just like this. We're going to have the same restriction here for this function. Okay? Multiply. So we're just multiplying these. Okay, but it's still the same thing, right? We still have this x minus 5 can't be negative under the radical. We're going to have the same domain restriction here. And you might say, oh, it's going to be the same for all of these, right? It's like, oh, I see the pattern no matter what we do. But not quite. So let's see. So our f of x function is 3x squared. And now we're dividing by this g. Something changes here now, though, right? Because we still can't have the negative under the radical, just like we did here. But we can also divide by 0. So in this case, 5 does not work. If I put 5 in here for x, then the square root of 5 minus 5, that's the square root of 0. That would be 0. And so I can't include 5 for this one. So the domain on this doesn't include 5. Notice, that's not a bracket. Okay? So 5 doesn't work here. But the number right next to the right of 5, directly to the right of 5 would work. Okay, 11. For the following exercise, find the indicated function given f of x equals 2x squared plus 1 and g of x equals 3x minus 5. All right, so what we're going to do here is we're going to work our way from the center out in the function. 2 is my input value, x, for my g function. So let's start with that. I'm going to say g of 2 equals, now I'm putting 2 into the x for the g of x. So it's going to be 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. Now we're going to put this output is going to go into the f of x function. So we're replacing x here with 1. Okay, so here's our f of x. We're putting 1 in for our input. So the output of the g of x is the input for the f of x. So f of 1 is 3. Okay, f of g of x. Okay, right now I'm just using x as the input, and we already have that here. So all we're going to do here is we're going to take this right here, and we're going to put it in for that x right there. So f of g of x equals, okay, so I'm going to write the f of x function, but I'm going to put parentheses for the x right here. I'm just going to put a big set of parentheses right here. And instead of writing x, we're replacing the x with the g of x. Okay? And I think I'm going to leave it like that. Okay, we could expand this. Do a 3x minus 5 times 3x minus 5, get a trinomial, multiply by 2, and then add the 1. I think I like that. I think we'll leave it like that. Okay, now we're seeing this composition of functions right here. So g of x. So this means we can write it like this. G of x. All right, so what is g of x? So g of x means we're going to take 3, instead of x, I'm going to leave that in parentheses. And what are we putting inside to replace this x? Well, a whole nother g of x. So we're going to put 3x minus 5 in for the x here. And then now I think I will distribute this. 9x minus 15 minus 5 is 9x minus 20. I just did D, didn't I? Kind of went out of order. What's this over here? C and then E. Sorry guys. All right, so let's do G of f of x. G of f of x. So I'm going to take the f of x function right here. I'm going to take this and I'm sticking it into the x for the g of x. So I'm going to write the g of x function here. And I'm going to replace the x of the g of x with whatever the f of x output is. Just like that. And let's see, why don't we distribute this? 6x squared plus 3 minus 5. 6x squared minus 2. Is that one? Now, f of negative 2. So this means we're doing f of negative 2. All right, so that means I've got, why don't we find f of negative 2 first? And then we'll put that into our f of x function. So f of negative 2 means we're doing 2 times negative 2 squared plus 1. Okay, here's our f of x function there. And negative 2 squared is 4. 4 times 2 is 8, plus 1 is 9. So f of negative 2 is 9. And then we can put 9 into our f of x. So we're saying f of 9 equals 2 times 9 squared plus 1. 2 times 81 plus 1. 2, let's put this over here. Okay, 2 times 81 is 162, plus 1 is 163. Okay. There we go. Okay, so we have 4 left. Find f of g of x and g of f of x. Okay, so f of g of x. So I'm going to take my, I'm leaving a blank, I'm leaving parentheses for that x there. What am I putting in there? Putting in my output for my g of x is x squared plus 3. For this one, that doesn't simplify. Can't take the square root. Don't say square root of x squared is x, because we have this whole binomial. So we're going to leave it like that. Okay, and then let's do g of f of x. Zoom in here. So that means I've got my g of x function. All right, here's my g of x function. But I got x here, but instead of writing x, I'm going to input my f of x function. Okay, this one we could square. So this is the same as saying square root of x plus 2 times the square root of x. That's not it. Doesn't look like an x. Okay, first, square root of x times the square root of x is x. outer square root of x times 2 is 2 root x. 2 times root x is 2 root x. 2 times 2 is 4. Guys, I'm just foiling here. Okay, x plus 4 root x plus 7. That's our answer for that. I'm going to take my f of x function right here. Instead of x, I'm going to replace it with g of x. Okay, well the cube root of x cubed down here, that would at least give us x, right? Cube root of x cubed. And then in the numerator, there's nothing to be done. We could write it like that. Hope you see we would have a domain restriction, but it didn't ask us for that. X could not be 0, right? 0 wouldn't work for the domain. G of f of x. Let's write the g function here. So anywhere I have an x, I'm going to put parentheses. Okay, so there's an x there and an x there. And so we're going to put the f of x in for that x. So this is going to be cube root of x here. And then this one is going to be the cube root of x here. And then the cube root of x cubed right here would cancel and leave us just with x. And then in the numerator, I got the cube root of x plus 1. And then that's all we can do for this one. Again, we would have a restriction on the domain because we're dividing by x. Okay. F of x, f of g of x. Okay, so I'm going to write my f of x function. Instead of x, I'm going to just put parentheses. And what goes in there, we're going to say 2 over x plus 4. So now the plus 4 and the minus 4 cancel. So it gives me 1 over 2 over x. I have a compound fraction here. How about I multiply top and bottom by this reciprocal? Cancels all of this. And I'm left with x divided by 2. G of f of x. Let's take my g function here. Instead of x, I'm going to write parentheses. And now I'm plugging in the output for f of x is 1 over x minus 4. How about we multiply x minus 4 top and bottom here? So if I distribute that, I get 2x minus 8. See in the denominator, these cancel. And then I have a plus 4 still sitting out over here. And then 2x minus 8 plus 4 is 2x minus 4. And that's my answer for that one. Okay, last one. Find f of g of h of x. Let's work our way from the center out. Why don't we first take a look at g of h of x. And whatever this is, we'll plug into the f of x function. So g of h of x. So we're going to write the g function here is 1 over x, but instead of x, I'm going to replace it with the h of x function. Okay, now we're going to take this whole thing and we're going to stick it in to the f of x. So we've got f of g of h of x. Here's my f of x function. X squared plus 1. Instead of writing x squared, I'm going to put this parenthesis, and what goes in there? This does. So this is 1 over x plus 3 squared. And I think I'm just going to leave it like that. I don't think I really want to work that out. I think that's fine. We can work with that. Okay, guys. There we go. We just did 1 through 19. It was a good bit of work. Hope all that makes sense, and I'll check you later.